Hi, I'm Liz Nedden. Let's have a look at calculating the mean, standard deviation and the variance when we have discrete random variables. So there's a few ideas I just want to go through before we get into the example. So one of the ideas is that data can be represented either as a table or a bar graph. So you'll notice that I've got, for example, I've got my probability that x is equal to a number, and that's the same on this axis here. Then I've also got my values of x, which are 0, 1, 2, 3, and those match my x's along the bottom, 0, 1, 2, and 3. Now you'll notice that these are showing as bar graphs because we've got discrete data, not histograms. And then my probability of getting a 0, that's 0.2, matches up to that on the graph. And same with each of the different categories, those probabilities match up on the graph. We also notice that all the probabilities have to add up to 1. So 0.2 plus 0.4 plus 0.3 plus 0.1 all adds up to 1. So when we go to calculate the mean, remember the mean is a measure of the centre. Another name for it is the expected value. And we have a formula here that we are going to unpack very shortly. So this little sigma sign stands for summing up. Okay, or adding, and adding up multiple things. X, if I go back to that little table, x is my data values themselves, 0, 1, 2, 3, and the probability, well, those are the values 0.1, 0.2, 0.3, 0.4. So we want to sum that up, and I'll go through how to do that shortly. Then we have our spread, and so we're going to use the standard deviation to as an estimate of our spread. Now you'll notice in the diagram there, I'm showing the standard deviation as a way to measure the spread of the data from the mean. So I've got my line here in the middle, which is the mean value, and I've got arrows on either side of it showing it's the spread from the mean. That's what the standard deviation is measuring. So there are two different formulas for it. And we've got this first formula and then the second formula, and I'll go through separately how to use each of those. And overall we've got this sigma, so it's a little circle with a flick, and that stands for standard deviation. Underneath that, there's my definition of variance. So variance is the standard deviation squared. So these formula are all on our formula sheet for us to use for the exam. So let's try an actual example. So what I've got here is I've got my x values, 1, 3, 5 and 7, and I've got the probabilities of each of them, 0.1, 0.2, 0.3, 0.4. So I've got a little graph there which shows that what it looks like, and now we're going to calculate each of those things. So for our mean, here is our formula. We want to sum up x, and the little dot means is another way of saying times, so x times its probability. And we're going to add those up. So let's try using that. So here I have my x value. So I'm going to start with my first x value, which is 1. And I'm going to write that down. And I'm going to multiply that by its probability. So its probability, the probability of getting a 1, is 0.1. Then I'm going to add. So that's what that summation sign means, to add. Now I go to the next x value. So the next x value is 3, and I'm going to multiply by its probability, which is 0.2. Then I go back to my summation sign, and I say plus, and I repeat this again, x times the probability, 5 times 0.3, plus 7 times 0.4. I put that into my trusty calculator, and that will give me a value of 5. So that tells me for this data set, that's got a mean of 5. So if I look at when I graph that data, that's telling me that's where the mean is right on that value of 5. So I can see there I've got about 30% of the data below it, I've got about 40% of the data above it, and at 5 I've got my remaining 30%. So that's why the 5 is the mean. So now let's think about the spread. So we've got these two different formulas for standard deviation, and we'll use each of them. So we'll get the same answer when we do it, but I want to just go through how those formula work. So here's the first one. And so what we have is we've got our summation, so adding, and it says take each x value minus the mean. So that symbol there means the mean. So take each x value, subtract the mean, square that, and then the little dot there means to multiply by the probability. So let me start with the first x value. First x value is 1. So I'm going to do 1 minus, and our mean was 5, and I'm going to square that. Then I'm going to multiply that by the probability of a 1, which is 0.1. Then I'm going to sum this up. So now I'm going to add on the next x value. So my next x value is 3. So I'm going to say 3 minus the mean of 5, all squared, times the probability of a 3, 0.2. Back to the beginning, plus the next x value minus its mean, 5 minus 5, all squared, times its probability, 0.3, plus the last x value, 7, minus its mean, all squared, times its probability, 0.4. And I'm going to put a big square root over all of that. I'm going to carefully calculate that on my calculator, and that will give me an answer of 2. So that means I've got a standard deviation for this discrete random variable of 2. Now let's try this again using the other formula. So this is my other formula. So this is now saying the expected value of x squared minus the expected value of x all squared. So the expected value of x, that is my mean. And I've already calculated that in the previous one, so that was a mean of 5. Now what I want to do is I want to find the expected value of x squared. So in my table, I've got x. Now I need to find x squared. So if x is 1, 1 squared is 1. If x is 3, 3 squared is 9. If x is 5, 5 squared is 25. If x is 7, 7 squared is 49. So on the side here, I need to find the expected value of x squared. So let me just remind you of that formula. It said take the x value and multiply that by its probability. Or in this case, we're going to take the x squared value and multiply by its probability. So I'm going to have 1 times its probability of 0.1 plus 9, so I've done 1 times its probability plus 9 times its probability plus 25 times its probability plus the last one, 49 times its probability. And that will give me an expected value of x squared (29). Okay, so now that I have the e of x and the e of x squared, I can put them into this formula. So it says take the square root of e of x squared. So I've just found that. That's my value of 29. And I want to subtract from that my mean, which is 5, and I've got to square that, so 5 squared. So then I'm going to take the square root of 29 minus 25, which is square root of 4, which gives me a standard deviation of 2. So the last bit that I want to do is find my variance. So jumping you back to here, we can see that the variance of x is equal to the standard deviation squared. So both of the ways that we did it, we got a standard deviation of 2. So what we want to do now is find its variance. So the variance is equal to that standard deviation squared, which in this case will be 4. So that's how we do it using our calculations. But now I want to have a little look. Can we do this on our graphics calculator? And I want you to be able to use both methods. So I want you to be able to both do it by hand and on the graphics calculator. So let's have a look at how we would do this on our graphics calculator. So what we're going to do is we first of all need to go into statistics mode. So I'm going to go across to the stats mode and I get to this screen. Now I need to enter that data that I have in a table. And the table that it's got there, it's just reversed which way around it goes. So it's got, we need to do a column of X and a column of the probabilities. So I'm going to have 1, 3, 5, 7 going down, and 0.1, 0.2, 0.3, and 0.4 in my second column. So that's what I just want to enter now. So I'm going to do 1, 3, 5, and 7. And then I'm going to go up across to the next column, list 2 there, and I'm going to do 0.1, 0.2, 0.3, and 0.4. Okay, so there's my data. Now what I want to do is some calculations. So you can see there that we've got our calc option, so that's F2. So I'm going to press F2. And I've got these options that come up now. This is a one variable one that I'm going to do because I've just got one variable, X. And so I'm going to want F1. But just before I do that, I need to go into settings. So I'm going to go into the settings, so that's F6. Now what I need to do particularly, because I want the one variable, you'll notice it's got the first one variable X list says list 1. So that was the first list, that's fine, that's my X values. But now it's got one X var frequency is equal to 1, and that's not the right column. I want this frequency column to be the second column because I entered my probabilities in the second column. So I'm going to click on the list, which is F2, and it'll ask me which list number do you want, and I'm going to say, well, it was column 2 that I entered that data in, and so now it's changed that to list 2. So when you go into your exam, we will reset the calculator, and so you'll need to remember to do this at the start of that exam. So now that I've got that sorted, I'm going to press exit, and I want the one variable analysis now. So I'm going to click on F1 to get the one variable results. And that gives me a whole bunch of information there. So I can see the first one, X with a bar above it, that's another way of writing the mean. So it's gone and calculated that for us. So that's got a mean of 5. Then underneath that, we've got, for example, the third one, our 29. That's the sum of the expected value of X squared. And above that is this expected value of X. So if I need to use those formulas, that's there for us. But underneath that, I've got X and then my little sigma, so that's the standard deviation with the little flick. And I've got two different ones. I've got one which says n and one which says n minus 1. We're not going to use the n minus 1, that's a sample one. We use the population one. So there's our standard deviation value of 2. So that goes and does a lot of those calculations for us. We just need to know how to enter it and interpret those results. Thanks very much for watching.